Good morning, class. We are looking at section 1.6, sequences and difference equations. Here's the finishing part, part 2. Here's the last example. Pacific salmon population. Populations have discrete breeding cycles in which they return from the ocean to stream to reproduce and then die. This occurs every 1 to 5 years, depending on the species. Suppose that each fish must first survive predation by bears while swimming upstreams. And predation occurs with the probability of D. After swimming upstream, each fish produces B offsprings before dying. The stream is then stocked with M additional newly hatched fish before all fish then swim out to sea. What is the discrete time recursion for the population dynamics, assuming that there is no mortality while at sea? You should count the population immediately before the upstream journey. Here's the second method. Suppose that instead of preying on fish while they swim upstream, bears do so only while the fish are swimming downstream. What is the discrete time recursion for the population dynamics? Again, assume there is no mortality while at sea. And part C, which of the recursions obtained in parts A and B predicts the largest increase in population size from one year to the next? Justify your answer both mathematically and in terms of the underlying biology. You can assume D is between 0 and 1, B is larger than 0. By the way, D is the probability. The probability is always between 0 and 1. By the way, it can be equal to 0 and can be equal to 1, but in this case, it's somewhere in between. So let's look at this and see what happens. So for the first case, we have some fish to begin with. So I'm rewriting the question, part A. How many fish do we have? Let's say N, X, Y, Z, any variable of your choice. Let's say N sub T. So they swim upstream and predation happens. They are being taken by bears. And the predation has a percentage of D. That means 5%, 10%, 20%. So however this many is, times D will be subtracted from it. So in other words, N sub P, I'm going to call it, after predation, is the original size minus D times N sub T. I hope you understand that, which is 1 minus D times N sub T. Again, one more time. If what this means, if N sub T, the D is 5%, 1 minus that, 95% remains. If D is 10%, 1 minus that, 90% remains, and so forth. So that's after predation. After swimming upstream, each fish produces B offspring. So each fish produces B offspring. So in essence, we have to multiply this by B before dying. So there are a couple of ways to look at this. One is that whatever this was, plus B times N sub P minus N sub P, or just multiply this one by B. This is an easier way to look at it because they don't survive themselves. That's why I put N sub P minus N sub P. So however many we have here, just multiply it by B accordingly. Just multiply it by B. That's an easier way to see it. Then we add how many? M. So this number, add M. It's that simple. You're done for the first part. A quick recap. We have so many to begin with. A percentage is gone because bear's taken. So 1 minus D times N sub T. Each one that gets up there gives us B offsprings and they die. So B times this part. And then we add M. That's one way. Second way, Instead of preying on fish while they swim upstream, it happens when they go downstream. So again, we have the same amount to begin with, n sub t. Each fish produces B offspring, so B times that. Remember, plus n sub t minus n sub t because they die. So just B times that. Then we add how many? N. Now, all fish face predation, so all of them have to deal with that. So if there is a 5% predation, 95% remain. If it's 10%, 90%. So 1 minus D times this number. I hope everybody understands it's the complementary event in essence. That's it. Now the last part says, okay, which one? So we got part A, we got part B. Which one is more, this one or this one? That's really the bottom line for the last part. Which of the recursion obtained in parts A and B predicts the largest increase in population size from year to year? Well, we can discuss it from a biology point of view, or we can just do the math. As far as the math is concerned, all you have to do is subtract one from the other and see what happens. If I say part A minus part B, and the result is positive, if I can prove that this gives us more, if it's negative, this gives us more. So part A minus part B. So part B, A minus part B. And you just have to do the math. It's a simple addition subtraction. So this one, B times 1 times n sub t is B n sub t, B times D times n sub t minus B D n sub t plus M. So that's this part. We multiply this, 1 times B n sub t, so B n sub t plus M minus dB n t minus dm, or md. So we're going to do that. So I'm just distributing, I'm doing elementary math. I'm distributing. So I'm going to write this, and this one I'm going to distribute the negative sign. Each one changes sign. These two cancel each other. These two cancel each other. These two cancel each other. We end up with MD, and MD is positive because M, the number that we added, right, is positive. So is D. D is between 0 and 1. So therefore, part A gives us more. And here's the reason, if you want to think a bit about the biology. Part A, all additional fish survive. Part B, all fish, including the one that we added, those M fish, face predation.